Hi, all, and good morning. Thank you so much for joining. Happy to have you all here today. For those of you that joined us last week at our keynote on accelerating AI with intelligent automation, welcome back. For those of you that are joining us for the first time today, welcome. My name is Maeve Donovan. I'm a Senior Product Marketing Manager here at Dremio, and I'm excited to kick off our series of deep dives on our latest spring release, starting off with our very own Shirang, who will go through autonomous performance and what that means with Dremio. With that, I will pass it off to Shirang.
Thanks, Maeve. This is Shreyang, Principal Product Manager at Dremio. So, you know, we are truly excited to roll out autonomous reflection in version 26, designed to deliver seamless performance acceleration for AI and BI workloads. So before diving deep into what's new, let's take a moment to recap what reflections are for those who are not very familiar with reflections. So today, hundreds of Dremio customers leverage reflections to deliver or achieve sub-second response time for their workloads, spanning diverse sources and formats in different sources that are optimized and not optimized for large-scale analytics. So, what are reflections? Reflections are optimized materializations of tables and views that are often compared with materialized views, but they go much further. We kind of think of reflections as relational caches, and here is why. Because a lot of times, the users that are actually running queries are not familiar with reflections. They are running queries on tables and views that are most familiar to them, and Dremio under the hood will substitute reflections in query plans to generate optimal plans and accelerate queries. So what's the relationship between reflections and queries? A single query could leverage multiple reflections to generate the optimal plan and run in the fastest possible time. And in the same lines, a single reflection could accelerate multiple queries of unique type. Okay? There are two kinds of reflections, or two types of reflections, you may say: raw reflections and aggregate reflections. Raw reflections are created to, to materialize complex views or migrate and reorganize data from non-optimal file formats to optimal file formats like Parquet, backed by Iceberg table. And aggregate reflections, on the other hand, are used to summarize data in tables and views using combination of dimensions and measures, especially for accelerating BI queries that typically have data aggregations. So the question now is, who creates these reflections and how are they maintained? Traditionally, data teams that are responsible for managing performance will create reflections. Reflections are maintained or updated using incremental update process, right, for efficiency. You can use schedule process inside Dremio that is either time-based or interval-based to trigger reflection refresh, or you can also use REST API and a SQL command to trigger them programmatically. In a recent release of Dremio, we have also introduced live reflections on Iceberg tables. These reflections update automatically when the tables change, and that it basically makes it more seamless. Okay. With that about reflections, let's look at what value is autonomous reflection bringing. Prior to version 26, reflections were manual. Data teams that are responsible for performance management analyzed query workloads, found performance bottleneck, and created reflections. Right. This reflection creation process was time consuming and it put a lot of burden on central data teams, especially for organizations where workloads kept changing and or had too many workloads to manage. Now, even after creating reflections, these teams had to manually configure and monitor reflection refreshes to ensure data freshness. This created risk. If reflection refreshes weren't set up correctly, stale data could impact business critical decisions or downstream dashboards. So with autonomous reflection, we are eliminating this complexity. Now, Dremio automatically creates and manages reflections based on user query workloads. It not only ensures performance, but also ensures data freshness. Automatically created reflections stay up to date with real-time refresh that is directly tied to changes in the data or the data sets on which they are based. Additionally, any reflection that is automatically created is not leveraged to accelerate queries if they are found to be stale or not synchronized with the data on which they are based. So with this, we not only have eliminated the effort that is required from the user side, but we are also providing guarantee of data freshness and quality while accelerating queries. So let's take a moment to understand how autonomous reflection will fit into the workflows of different personas in the modern data ecosystem. We have data consumers that are typically domain experts. They understand data and use cases. This persona defines business logic using views and data products. And then you have users that are consuming these data products or views using AI or BI applications or tools like Power BI and Tableau. Now, these users expect fast and consistent performance. Here is when autonomous reflection makes the real impact. Dremio behind the scene collects data from the queries that are run and then analyzes these queries or metadata about these queries to find the right reflection to accelerate these queries from the users. These reflections are not only created, but also managed by Dremio. And then Dremio Query Planner can transparently use these reflections to accelerate queries that are coming from the user side. So what's the result of this? We have data consumers now that can focus on delivering business values. The end users that are actually accessing data gets fast and consistent performance. Data platform teams can spend less time on manual tuning and can focus on other more strategic important tasks. Okay, so let's look at the autonomous reflection life cycle. If you think about autonomous reflection life cycle, there are a total of 6 steps. The first step is collecting information about the user queries or query patterns. The next step is recommending reflections based on the telemetry collected. The third step is cost analysis that determines the value of newly suggested reflection or existing reflections. The next step after that is making a decision to create or drop reflection utilizing the data provided by cost analyzer. The step after that is maintaining reflections. We want reflections to be automatically refreshed, reducing operational overhead. And the last step is to leverage this reflection to transparently accelerate queries from the end users. And I'm going to dive deep into each of these steps in my slides, the future slides. Okay, so the first step is data collection. Collecting data from user queries is an asynchronous process, and it is done with no impact on user queries. Any data that is collected from the user is stored in the customer meta store in their environment, and it does not leave the customer VPC. So what exactly are we capturing? We collect usage information about the views that are expensive and frequently accessed, and the ones that don't have reflections on them. We capture information about the query fragments that are expensive and that could benefit from aggregate reflections. And the last, we collect information about the queries or the real jobs that are run that are later leveraged to evaluate recommendations or to evaluate recommendations. So the next step after collecting information is processing this information to generate recommendations. Dremio uses data from last 7 days and analyzes it during off-peak hours, typically at midnight. The output of this analysis, Dremio generates two types of reflections. Raw reflections for views that are frequently accessed and expensive and that do not have raw reflections. Any view that have dynamic or non-deterministic functions are ignored because the output of these views are different at different times of day or depending on the user executing these views. For aggregation reflection recommendation, Dremio uses query fragments. These fragments are evaluated in a bottoms-up approach to maximize the reuse of the recommendation that is generated. Any high-level filters or filter clauses are skipped to maintain dashboard flexibility. Okay. Dremio intelligently evaluates every reflection, whether it is already present in the system or being recommended, to ensure that we only generate reflections or maintain reflections that have maximum value. Here is how this process works. So the Dremio takes actual queries executed by users in the last 7 days and replans them with and without reflection recommendations. The output of this is used to estimate the potential speed up or the time saving of using reflection. Now, the factors like the number of queries a reflection could accelerate, the potential speed up, and estimate of time saving is used to compute a score between 1 to 100. And all the recommendations as well as reflections are scored using this method. The step after this is actually creating and dropping reflections. Now, when we are at this step, we have two lists that are ranked based on their scores, one for existing reflections and one for recommendations. These two lists are then used to make a decision on which reflections should be created and which reflections should be retained. Now, once we have made the decision, at this point, there are two two flows or two different modes of operation that users can choose from. The first mode is when you have autonomous reflections enabled. And when it is enabled, Dremio will automatically create or drop reflections based on the decision of autonomous reflection algorithm. If you have not enabled autonomous reflection, the action to create and drop is presented to end users in Dremio UI, and users can then evaluate and then apply these recommendations. So the very important step about any reflection process is the maintenance or keeping them up to date. Because when they are not up to date, using them in query plans could generate inconsistent or unreliable data. Dremio ensures that any autonomous reflection created is refreshed automatically whenever the underlying data set changes. So for iceberg table, it is when the iceberg tables change. And for Parquet, it is when the metadata for Parquet is updated. Right? Dremio utilizes smart incremental refresh. For append-only workloads, it only updates reflection based on the new data that is appended. For workloads that mutate data and they are partition based, then only partitions that have updates are recomputed to make refresh efficient. Use of reflection is transparent to users, as I've said before. The end users keep running queries, and then Dremio transparently accelerates these queries. With autonomous reflections, we are guaranteeing data freshness. That means only reflections that are fully synchronized with the underlying data set are used to accelerate queries. So how do we enable autonomous reflection in version 26 that we just released? In the preferences page in the Dremio UI, you can toggle a switch to enable autonomous reflections. When the switch is enabled, Dremio will automatically create and maintain reflections on your behalf. When the switch is not enabled, which is the default behavior, the actions are presented to you in Dremio UI as recommendations, and you can actually view and review them and then apply them as per your convenience. So, we have tried autonomous reflection in our internal data lake for almost 4 months now. It was turned on December 31st, and it's almost like 4+ months it's running. The value that we see today in our internal data lake without any user involvement is 80% of the jobs are now autonomously accelerated. And the average or the mean response time has gone down from 80%, has gone down from 10+ seconds to 1 second. So that's the value of autonomous reflections. We have really happy and surprised users in our internal data lake that have benefited from autonomous reflections. And you can take advantage of that too. So let's get started by running these queries in Dremio console to establish baseline. As you can see, these queries are taking time to complete. And this is typically what our customers see. Now my queries are finished. Each have taken between 3 to 4 seconds each. And you can see that none of these queries were accelerated. So let's go and inspect the state of reflections from reflections page. I have 3 reflections. They were not leveraged in accelerating my queries because they are on a completely different data set. In version 26, Dremio will analyze query patterns and automatically create reflections. This process typically happens at midnight, but for demonstration purpose, I'm going to trigger this process using a REST API. Let's refresh my reflection page to see if there is a new reflection created using autonomous process. Yes, there is a new aggregation reflection. It has a footprint of 1.56 MB and it took 5 seconds to refresh. Now I'm going to go back and run my queries one more time. As you can see, queries are running fast. This dramatic improvement was achieved without any manual intervention. This is power of autonomous reflection. Let me take it a step further and change my first query, which was grouping on hour of a day to month of an year. Yes, the query ran and it took just less than a second to run. So I'm going to go back to the jobs page to see if it was accelerated. And you can see this query was accelerated. Yeah, so this was a quick demo about autonomous reflection. And I'm here now to take any question that you may have about autonomous reflections or reflections in general.
Perfect. Thanks, Shirang. So it looks like we do have one question already come in, being can there be multiple autonomous reflections on the same view or table? And then also, are we able to see how these autonomous reflections are set up? So let's start with that first part. Can there be multiple reflections on the same table?
Yes, you can have multiple reflections, autonomous reflections on a single table or view. And this is typically true for even a reflection. A single table or a view can have more than one reflection. Now, what autonomous reflection does is it will add reflections only when it finds it will help user cases, right? So yes, the answer is yes, you can have. The total number of autonomous reflections that Dremio creates today is limited or max to 100. But if there is a specific table that we see a benefit of adding more than one reflection, we will add it.
Perfect. And we did get to see how those reflections are set up within the demo there. Any other questions anyone has, please feel free to drop them in the chat. We'll be happy to answer. While you are putting your questions together, I would recommend looking at Shirang's great blog that came out with the release of our spring release. It has a lot more information of what he went over today around autonomous reflections, as well as links to our documentation there as well. I see another one dropping in. A question here for you, Shirang. Are we able to set when autonomous reflections will kick off? We load data daily in the morning, so if it only kicks off at midnight, we would not have the updated data in those reflections. Or would that cause the reflection to automatically update?
So any autonomous reflection is no, okay. One thing that I missed here in the demos, in my presentation today, the autonomous reflections are today based on iceberg table and Parquet dataset only. And so one thing about autonomous reflections that they are live. So that means any data change on the underlying data set, right? It could be iceberg table or Parquet dataset. Whenever a iceberg table changes or a Parquet metadata for Parquet dataset is refreshed, Dremio will automatically trigger reflection refresh. And keep reflections up to date. During this process, when it is updating the reflection, if a query comes in, then Dremio may figure out that the reflection is not up to date and will not leverage reflections. Because our end goal is the end user should always see the same results, whether the reflection is used or not used. Okay. Another fact that I just want to bring out here, and which I missed, is a lot of data about the value of autonomous reflection as a whole, or a specific reflection that we have created, is available to you in Dremio UI through different monitoring dashboards. And you can use reflection page in Dremio UI to actually see the reflections that we have created and the value that's bringing.
Awesome. A few more questions here. For queries to be analyzed as part of reflections, I know you mentioned they need to be on Iceberg or Parquet. Do the queries have to be submitted to Dremio? If the table is being used by a remote database application, can that remote database have its queries accelerated?
No. So Dremio collects metadata about queries that are executed using Dremio query engine. But it is okay if the table on which your queries are running through Dremio is updated using other engines, and that's fine. But the queries analyzed need to be run using Dremio engine.
Great. And then what is the overhead of computation to perform the overnight performance analysis as percentage of the computation used by the engines during the day to respond to user queries? Is, as an estimate, 10% of the daily workload, 20%? I would go ahead and, obviously, Shirang, you're the expert here, but say this is dependent also on the size of the queries, the size of the data, the frequency with which the refreshes happen.
Yeah, so there are two steps here, right? One is the data collection. The data collection is a lightweight process. It's a asynchronous process, and any data that we collect is also aggregated, to basically minimize compute at the time of analysis. The analysis is a fairly lightweight process. It runs on the coordinator. A lot of activity is mostly replannings of some of the actual jobs using recommendations to figure out whether the recommendations are useful or not. And output of this could be that we may create a new reflection. That reflection needs to be refreshed using a refresh engine. That is like additional computation. And then depending on how frequently you update the underlying tables, this reflection needs to be updated. That's the additional incremental load on the compute. So if you are leveraging autonomous reflections or reflections in general, we recommend dedicated refresh engine that is separated from user query workload to isolate reflection refresh jobs from user query jobs so that they don't step on each other. In version 26 now we also have engines on Dremio software that can automatically shut down on idle and restart. You can leverage that functionality for your refresh engine.
Awesome.
To keep costs low.
Yeah, perfect. I know we have a lot of questions here, so just going to bring in one more that we have. Coming in saying, first off, excellent feature, definitely value add for sure. Thanks to you, Shirang, for a great walkthrough. Their first question is, how much data is needed for this to be effective and efficient? And the second one, where can we find Shirang's blog? I have linked the answer within that chat for any of those interested. So how much data is needed for this to be effective and efficient?
So for us to create reflection, it's again, as I said, it's based on three factors: the number of jobs that we will accelerate, uh, the speed up factor that decides, like, how what's the impact of reflection on the jobs, and the last is the total time saving. For us to compute it and be you know be more conservative, we need data from at least 2 days to make this decision, right? So Dremio basically analyzes 7 days, but within these 7 days, we want to see the pattern for at least 2 days to be sure that the customer is going to run this more consistently versus it was just one time thing that they ran like 10 queries and then didn't go back.
Perfect. Well, I know we've had Shirang answer a lot of questions here. There's a lot of great, interesting content. And like I said, if you want to learn more, please go look at his blog, which is linked in the chat. There's some great information there, as well as links to all of our documentation. You can also learn more on our website, on our Reflections webpage. But I do want to give a big thanks to Shirang here for such a great presentation, and also for all the hard work him and his team have put on this project. It's exciting to see the evolution of reflections into autonomous reflections and getting to see all of the great value that a lot of our customers are already seeing from it, as well as Dremio ourselves. This has been a great presentation to start us off.
So we also have a technical blog to go along that for technical users that want to dive deeper. We have a technical blog also for autonomous reflection that we can share.
Yes, definitely. I will link that in the chat as well. But I want to say, first off, thank you to everyone for joining. Do really appreciate it. I would encourage you to come back next week on May 13th at 8 a.m. Pacific, 11 a.m. Eastern for our session getting started with Dremio's MCP server. There'll be also, similar to what Shirang presented today, a great presentation going through all things MCP server, why Dremio decided to build ours, and a demo of that as well. We look forward to having you all there and looking forward to seeing you in the subsequent ones as well on May 20th and May 27th, going over Enterprise Catalog powered by Polaris, as well as data discovery with AI semantic search. Thank you all for your time today. We do appreciate it and look forward to seeing you in the next.
Thank you.